Hey everyone, it's Ben from Board to Bits, and welcome to part 4 of our series on making a custom character controller in Unity. So at this point, we've got our script set up so that our device tracker will populate an input data struct and then pass it to the input manager, which can then tell our controller what to do. With all that set up, we can actually get rid of our basic controller off of our player script, since it's no longer going to be what we're using to take in inputs and move our character. So we'll remove that component, and I'm going to create a new empty object. Make sure it's at 0, 0, 0, and I'm going to rename this, and I'm going to call this Input Manager. You could put this right onto your Game Manager object or whatever you'd like. I'm going to just create a separate object for it for right now. And here we're going to add, we're not going to actually add the Input Manager, we're going to add the keyboard tracker that we created. You'll notice we can't add the device tracker. It doesn't appear because it's an abstract class, but our keyboard tracker we can add. So we'll add that on, and it automatically puts on our input manager because we required that component for it. So our keyboard manager is ready to, populate the input data struct, as we said, but it doesn't know what it should be populating right now. It doesn't know how many axes we need, how many buttons we need, all of that sort of information. And that sort of information is actually going to be held in the input manager, because the input manager ultimately knows, oh, I need this many axes for the various controllers that I'm going to be passing this information to. So let's jump over to our script and add a couple of variables so that we can tell our program how many axes we need and how many buttons we need. So we'll jump into MonoDevelop, go over to our input manager, and right up at the start, we're going to add two ints. So we're going to add a public int called axis count and a public int called button count. Now, I'm going to add a range attribute to both of these because we're never going to want a negative number in either of these, and we probably want to keep this to a somewhat reasonable range of numbers here. So I'm going to say bracket range, then we're going to say from 0, it's saying float there, but because we have an int, it's going to automatically know it's an int. 0 to, we'll say 10 axes. I don't foresee us ever actually using 10 axes, but somewhere between 4 and 6 is possible. 4 is actually if you're doing anything like a twin stick shooter or a first-person shooter type of game where you've got one set of axes for movement and one for moving your camera around, you would have at least 4 there. We'll say 10 to just give ourselves a little bit extra. We don't know exactly what we're going to need for our flight controller and things like that. And likewise, for our button count, we'll say range, we'll say 0 to 20 here. Again, I don't think we'd ever use that amount, but especially on a keyboard, you do have a little bit more flexibility in how many buttons you can have, so we'll just put an extra kind of higher number there. But that does limit us to, so that we're not, putting thousands of buttons into our controller. We're going to save that. If we go back over to Unity, we should see that these both appear with these nice sliders so we can say how many we need. Right now, as of the last video, we said we're going to need 2 axes and 3 buttons, so we'll set both of those. We'll hit save there. And this is all we need. We don't actually need to list out any information here. Like I said, we're not naming our buttons, and we don't really care. The input manager itself doesn't care about the key codes. It just cares that it's going to be getting an input data struct that has enough axis information and enough button information for it to work with. So our keyboard tracker now is where we're going to be doing the bulk of our work. We are going to do a little quick thing in our device tracker, though, because this is where our keyboard tracker, if we had a mouse tracker, a gamepad tracker, etc., anything we do here will affect all of those, and we do want to add a little something here, which is in our awake function, after we set our input manager, we're going to actually take some information from it. We're going to take this axis count and button count and use it to set up our input data struct. Because our input data struct doesn't know, if we just create a new data struct, or a new input data, it doesn't know how many axes and how many buttons. We have to pass it that information. So let's add a line here. Data equals, and this is we're going to set up a new input data. And we're going to pass it the 2 ints from input manager that we have so that it knows the number of axes it needs and the number of buttons it needs. So we'll say im.axisCount im.buttonCount. And now we've populated so that we know our keyboard tracker is going to know when we start our program it has an input data struct with the proper number of axes and button information for it to pass along. So now we can jump over to our keyboard tracker. Now that this is all ready to go, we need to decide on we need to tell our keyboard tracker what buttons it should be looking for. So for our buttons, that's actually pretty easy. All we need to do for that, we can say public keycode, we'll make a keycode array, much in the same way that we're tracking our buttons through an array. And we're just going to call this button keys. However, it's a little bit more complicated for our axes. Because we're using a 2-button axis, we actually need 2 key codes, one for positive values and one for negative values. We could create 2 separate arrays that have both of these information, but I think it's going to be a lot easier for us in the long run if we create a new struct that contains 2 key codes, one positive, one negative, and so we can always just refer to that struct and then get the positive or the negative as we need it. So in order to do that, we're going to add this in our keyboard tracker. Because for a gamepad, for example, we'd probably be using a joystick and wouldn't need to worry about this. This is very kind of specific to the keyboard tracker. We're going to say public struct axis buttons. And this is going to have a public key code positive and a public key code negative. So now what we can do up here, and we're not going to create a constructor for this because I don't think we'd ever actually be procedurally making these right now. We can add one later if we need to, but for now all we need to do up here is say public axis buttons, make an array of those, and we'll call this axis keys. Oh, one last thing we do need to make sure we do is we need to make our axis buttons serializable. So we'll say system.serializable, which means that we can actually see our axis buttons in the inspector. We'll jump back over to Unity and we should be able to see now that we have an array set up for axis keys and an array set up for button keys. However, one challenge we have right now is that this obviously isn't reflecting the number that is in axis count up here. Likewise, button keys is not reflecting that either. Now we could, one solution might seem to be, oh, well, just in our device tracker or in our keyboard tracker, we can create an awake function and make sure that on awake we're setting it up with enough key codes for what we need. The problem with that is that that only happens when the game is started, and at that point we should already have our buttons in place. So we need to do it a little bit sooner than that. We're going to do that right now through what's called the reset function. So we say void reset. This is one of Unity's built-in functions, and if you've ever reset a transform, you've actually used this particular function. In the transform, it resets everything to 0, 0, 0 for position and rotation, and I believe scale as well. Here, we're going to create our own, and what it's going to do is it's going to set the length of our 2 arrays to match the input manager. So what we're going to do here is we're going to say reset, and we're going to actually set IM equal to getComponent. We're going to do kind of what we did in the awake function here, because technically this awake function may not have been called when we first, for example, when we first put this into add this component onto our game object, awake's not going to get called. So we need to make sure that we have this. I'm actually just going to copy this and paste it in here. And then we're going to say axis keys equals a new axis buttons array, and it's going to have a length of im.axisCount. Likewise, button keys is going to have a new key code array, and its length is going to be im.buttonCount. So now we know once we reset this, it's going to reflect that properly. And we can actually see this a couple ways. The first is if I were to just hit reset right here, we see now that it populates with 2 axes and 3 buttons like we've asked for. Be aware that this will reset all of your key codes at this time, so if you have a lot of information and you use this reset solution, it is going to wipe away any information you have. But we'll address that in a future video. The other thing that's kind of cool is that if we remove this component altogether, we can have an input manager without any trackers right now. It just obviously won't ever get any information. We could add our keyboard tracker again, and we should see that it has all of that information pre-populated because reset gets called whenever a component is first added to a game object, which is also pretty convenient. Now that we have our buttons and axis keys set up, we can actually decide what we want those keys to be. For example, for our first set of axis keys, we should right now probably decide on an order that the axes are going to be in, either vertical first and then horizontal, or horizontal then vertical. I think we'll go vertical first, so we're going to want our positive value to be W. And W, if you just type a W, it'll pop up there. However, other ones you might have to cycle through the list here. For example, my down key I want to be S, so we'll hit S a few times. There we go, that's the key. Just the single key there, not any other buttons. For the button keys, I want the primary button to be the space bar, since it's nice and big and easy to hit. I'll just find that in the list here. And for our elements, I'm going to use the Z and X keys because they're and for the secondary buttons, I'm just going to use the Z and X keys because they're right below the movement buttons, so that seems fairly convenient, at least at this time. Obviously, we have the ability to change these at will, which is also nice and part of why we're setting this up as we are. So I'm going to have element 1 here, the secondary button, be the Z key, and element 2, the tertiary button, be the X key. So those are all set here. Can save this. Now that we know what these keys are, we want our keyboard tracker. Oh, I never actually set the horizontal axes. We want these, the positive will be D, which that will have to cycle through. There we go. And then the negative will have A. And A, you have to go through all these alpha, or we can just actually click it down here, A. So, have all those set up now. Now that we know what keys we're looking for, we can tell our keyboard tracker to actually look for them. So we're going to check for that down here. And we're going to start by checking for buttons, because buttons are a little bit easier. Neither are super complicated, but how we're going to do this, we're going to do a for loop. So we're going to say for, tab, tab to pre-populate it. I equals 0 is fine. And we want the max to be our button keys dot length, because we're going to cycle through all of our button keys. And for each one, we're going to check if input dot get key. We're not going to check if the key's down or up, like is it just being pressed this frame. We just want to know, is it down at all? We'll let the controller itself decide if it's important that it's just been hit, or if it's being held down, or if it's being released, etc. So if input.getKey, and normally here's where we'd put a key code, like key code W or key code S, key code spacebar, etc. But instead we can actually just pass in button keys and the particular index that we're on. So button keys I. If that is the case, then what we're going to do is we're going to take our data struct that we have, and data struct dot buttons, and this is an array as well, so we're going to give it that same index, equals true. If this is the case also, we know that we have some new data on this frame that we're going to want to be passing, so we're also going to set our bool that we have in device tracker, new data, equal to true, which is going to let the end of our function here know that it should be passing the data. So that's our buttons. Axes are pretty similar, actually. They just require two checks, one for positive, one for negative, and we do want to allow for the fact that both of them might be hit, particularly on a keyboard, because you can press both buttons at once. So we're going to copy this, actually, and paste it in here, but we're going to make some changes to it. So the first thing is that instead of button keys, we're going to be looking at axis keys.length. Here, instead of get key, we're actually going to have to do something first. We're going to want to set a float first. I'm going to have a float called val, and I'm going to set it equal to 0, because instead of just setting something to true, we're actually going to be we're going to be adjusting this value once or twice. So we want to make sure it starts as a neutral location and then can be set to 1 or -1 or even back to 0, depending on what our button presses are. So here we're going to say get key, instead of button keys I, we're going to say axis keys I. But not just that, because this is actually the axis buttons struct that we made. So we're going to first check for axis keys I dot positive. And if that's the case, we're going to get rid of this. And we're going to say val plus equals 1. So we're adding 1 to the value here. Then I'm going to copy all of this again, because we're going to double check this for negative as well. And here we can say val minus equals 1. And in both of these cases, if either one is hit, we want to make sure that new data is set to true. Finally, now that all this is set, we can set our data.axes at index I equal to val. So at this point now, we've set up a value, kind of just a dummy value at 0. If we're positive, we're going to make it 1. If it's negative, we're going to make it -1. However, if both are hit, it's going to add and then subtract 1, bringing us back to 0. Regardless, after all of that, we're just going to pass that value into our input data. And now that that's all set, we can actually, this is all set, and it's actually going to be passing in the proper data to our input manager. And we can check this out if we go to our input manager with this here, with this pass input function here. We're just going to do a quick debug log function, debug.log, to see if this is working. I'm going to just check the movement axes right now. We're going to say movement, and now we're going to check that data that we're passing in. We're going to check data.axes 0. We'll check the value of that. Plus, and we'll add a quick comma, plus data.axes 1, the horizontal axis. And so now what this should do is, when we're pressing a button, if we're not pressing a button, nothing should happen. But once we press a button and there's that input information, it's going to be passed to the input manager, and the input manager is going to say, hey, these are the movement buttons that are currently being affected at this time. So let's jump back over to Unity, see if we have any errors. We don't. Lovely. So I will hit play. Actually, I'm going to not maximize the game view so we can see here in the console what happens. Hit play now. So nothing's happening because I'm not pressing any buttons. If I hit the D key, we see that the movement is positive in the horizontal axis. If I hit W, 1 positive in the vertical axis. I can hit a couple at the same time and we get multiple forms of movement there. And I can also, if I say I hit the A and D keys, so left and right together, we get back to 0, 0 because those two are canceling each other out. Likewise, if I hit the space bar, we get the same effect because there is input being passed in, but it has nothing to do with movement. So that's really the core of how our input system is going to work. Is our keyboard tracker is responsible for just taking in whatever key inputs are there, and then just passes them to the input manager, which is really where the meat of kind of looking at that information, deciding what it means and which controller it should go to is going to happen. That said, there is one other thing I want to do with this system before we finish up with it, and this is going to be in our next video. But we see here, there's a couple of things actually that are a little bit lackluster right now. The first is that if I change our axes, as we've seen, I can change the axis number. This does not respond to it. The other thing is that we've created this nice struct with a positive and negative value, but they're really just kind of being stored not very elegantly here. There's multiple drop downs and things we have to look at, and then we've got a lot of lines here. If we had this on a game manager, it'd be taking up a lot of vertical space that we might want for other things. So I'd like to kind of compact this down into something like how we set up a vector 3 when we see it's all nice and in one line with kind of simple information there. So in our next video, we're actually going to be diving a little bit into some editor editor controls and making a custom inspector for this so that we can kind of make this a little bit sleeker and a little bit more responsive to what we're actually doing with it. So thanks for watching, and I'll see you next time.